Okie dokie. Students, good afternoon. We are going to review topics for tomorrow's test, which, as you know, is primarily about identifying or writing the function equations of graphs of sine and cosine waves. So you know what? Let's actually go to Desmos to do this. Okay, so let's look at this wave right here. So what I need to be able to do is identify A, B, H, and K, right? So let's kind of switch back and forth here. So we need to identify A. Uh-oh, is it going to let me do this? I hope so. No? Okay. A. Okay. And then either sine or cosine, then B. And then you have H, and you have K. And that kind of stinks that I have to do this with a mouse, but whatever. Okay, and this is either going to be sine or cosine. And we should probably also make this an equation. F of x equals, okay. So this right here, let's start with A. Let's start with A. A is the amplitude. So I'm just going to write amp. Okay. And the amplitude, okay, I have my center line here. Whoa, it's hard to draw with the mouse. Okay, center line there. Amplitude is just this distance. Oh my god, I can do better than that. How about let's use the lines. Okay, all right. Amplitude is this distance, which should be the same as this distance. So let's see, is that the same? I'm at 2 here in the center. And that's 1, 2, 3 to the top, 1, 2, 3 to the bottom. So the amplitude is 3. So we'll write that. Amplitude equals 3. And therefore, A is going to equal 3. So I'm going to start writing my real equation down here. The function of x equals 3. I'm going to get more here. In a second. Okay. Alright, so now let's deal with K, since that's so easy. K is your vertical slider. And that's true with every function. You notice, like, we've been using H and K all semester long. H is the horizontal slider, K is the vertical slider. That's been true with every one of these. So this is the horizontal slider. Okay, so let's go back to the graph here. Alright, so K, as I was saying, that's an easy one. K is just your position of or I should say the vertical position of the center line. Now let's think about why that is for a second. The regular, let's say, sine wave goes like this, approximately. Am I right? More like this, maybe. Pretty close. Okay, anyway, the center line of that function is right here on the x-axis. It's at 0, right? So if I were to translate this up, and remember, K, like we said, K is the vertical slider. It affects, you know, if we change K, we're basically shifting the graph up or down according to K. So if K is positive, we shift it up that many units. If it's negative, we shift it down. Okay? But we keep the same shape of the wave and everything. So if I took this sine wave and I just shifted it up so that it were here instead, right? Shifted every point up 2 units, right? My center line would wind up right here at 2. So I can look at the center line. The moral of all that story is that I can just look at the center line to tell what my K value is going to be. So my K value is 2. All right. So K is 2. So when we get to the end of this, we're going to have a 2 right there in this spot. Okay. So what about B? Let's deal with this. Now, there's a rumor out there that B equals the period. B does not equal the period. B equals 2 pi divided by the period. Divided by the period. Okay. b equals 2 pi divided by the period. So we go here, we look at what is the period. So the period, we can measure it here, or we could measure it here, or we could measure it. You know what I'm going to do? Watch this. I can do this and then say, hey, look, I can measure it there, there, there. You see how it's the same everywhere? Wherever I want to fit this thing, the period's the same. I could even just ride the wave. Whoa. I'm going to ride the wave with my segment that does not change in length no matter where I put it. Okay, so that should convince you that I can certainly just measure it. Look at that. It's about 3, or it's definitely more than 3, but you know, so we don't want to call it exactly 3. So you could call it like 3.2. And you know, let's say you don't have this tool to use on the test, so maybe you're saying, Mr. Teich, this is not fair. I don't get to slide around like that when I'm taking the test. So how would I actually do it on the test? Well, if you were totally desperate, you could just say, look, what's a good decimal approximation for this maximum? You look down here and you'd say, that's about 1.75. What's a good decimal approximation for this maximum? Let's say you said, okay, that's 5. So then you could do 5 minus 1.75, and that would be about equal to 3 1/4, which is close to what we were saying, right? We're starting to get a little off track with our estimates, but 3 1/4 is still close enough, right? Now, those of you who are, you know, pretty good at putting things in terms of pi, you probably said, Mr. Teich, obviously the period is pi, because look, this distance is a little more than 3. Period is almost always in terms of pi, so this is going to be 1 pi. Okay, and you would be right. So no matter how you slice it here, we could say the period here, the period of the function is pi. If you use an estimate like 3.1, like 3.2, or 3.25, which we were mentioning a minute ago, that's probably going to work. Even if you use 3, it's probably going to work, because what you're going to do is you're going to take 2 pi and you're going to divide it by one of these numbers. And no matter what you divide it by, or at least, you know, no matter which one of these you divide it by, you're going to get something pretty close to 2 for your value of b. If you use pi and you do 2 pi divided by 1 pi, you're going to get exactly 2 for your value of b. So we're going to say b equals 2. So we filled in our a, our b, and our k. All right. Now, we just have to pick an h. Now, here's the great part about h. You have so many choices for h. H could really be anything that is a peak or a rip. Okay, so let me get rid of some of this stuff that we don't need anymore. We don't need any of this, actually. And, okay. So, any peak or any rip, meaning that works for h. This value right here. This works for h. This value right here. This works. Make sure you make it negative if you choose one of these. Or we could make a rip, and a rip is a rising inflection point. This is not a rip, but this is. This is not a rip, but this is. So any of these points I'm labeling in red could be used as the value of h. If you choose for this to be a sine function, remember, this could be either sine or cosine. I'm going to either write sine or cosine in there. If you choose for this to be a sine function, you need one of these rips, because the parent function of y equals sine of x has its rip right here, or rather it would be right there on the y-axis. If you choose one of the peaks, then we got to do a cosine function. Okay, but you really do have all of these choices, and you could even zoom out and find more peaks to the left and right and more rips to the left and right, and there are infinitely many ways to write this trigonometric function equation. So let's just do sine, because who cares? 3 sine of 2 times x minus, let's say this one. That's really close to 1. it's a little more than 1. So we could either write 1.01, or, as some of you are guessing probably, we could write it in terms of pi. Pi over 3 happens to equal a little bit more than 1, so we'll do that. Okay, so that was pretty long-winded. We got our function equation. Let's say we do one more. Okay, so the bell might interrupt us, but that's okay. We're going to do this real quick. Okay, so amplitude. Okay, first I draw my center line. Wait, I can do better than that. Center line, bam. Okay, center line's at 0. That means K is 0. Amplitude. Okay, well, I can see it's 4. Bam, that gives me A right away. A is 4. Period. From here to here. Let's see, that's -7 up to 5.5. So let's see, that's -7 up to 5.5. If I subtract them, then I'm adding a positive, which gives me 12.5. I didn't line that up, but you guys know how to add. 12.5. Okay, so I could say that my period is 12.5, but you know what? I'm going to say that is 4 pi. Because that's probably the precise value of what it is. That means my B is 2 pi divided by 4 pi, which gives me 0.5, or I'll just write 1/2. Okay, I already have all this stuff. And now, all I got to do is H, and for H, get rid of this. For H, I just have to, there's the bell. Okay, for H, all I got to do is pick a peak or a rip. Peak, rip, which one's the best? Well, it doesn't matter. Let's say it's this one. Now, that's at about -0.75. We could just say H is that, make it cosine, and call it a day. But you might also realize that this is approximately -pi over 4. And so therefore it is probably exactly -pi over 4, since we're dealing with, sine and cosine and probably integer values for all these things. So we'll say that H is this, and we'll use cosine. Because this is a peak for my H, I'm choosing a peak, I'm going to use cosine. I could have chosen this and made it a sine. Okay, so let's write it out. F of x equals A times the cosine of B times x minus my H value, which is a negative H value. I'm subtracting a negative value, plus my K, which is 0. I can simplify by getting rid of this, because I don't need to show that I'm adding on 0. And not only that, I can change the negative, because it's minus a negative, I can change that to plus a positive, and there it is. So this is my function equation for this wave. Okay.